Okay, good morning, everybody out there. Thanks again for joining us in our third session of this Sharpen Your Dairy Skills While We Flatten the Curve webinar series. Been really pleased with the feedback and the viewership so far. So again, please send comments or suggestions. We're hoping to extend this series if we can come up with some additional speakers that are relevant. This morning, I'm really pleased to have my colleague, Dr. Adam Locke, as a part of this webinar series. So Adam grew up on a dairy farm in the UK and completed all of his degrees at the University of Nottingham there before coming and doing some postdoctoral work at Cornell University. He was on the faculty at the University of Vermont for 3 years and has now been at Michigan State for 10 years. Adam's really had a very vibrant, impactful, and relevant research program, and he's won numerous awards for his research, particularly the last 4 or 5 years. So Dr. Locke, if you want to jump in and get us started on some discussion of how to stretch forage resources, I'd appreciate it.
Yeah. Good morning, everyone. Hope everyone is doing well and staying healthy. I want to thank Barry for asking me to do this. So I'm going to jump in. I know Barry has a very interesting topic to follow up on this. So I'm going to give a little bit of data here on feeding strategies to stretch forage resources. And really what I'm going to show you is one study here. One study here where my master's student here, Ariana Negreiro, did for her master's work end of last year, early this year, looking at the effects of a low forage diet on the yields of milk and milk components of mid-lactation dairy cows. And as I'll show in a while, I need to acknowledge the Michigan Alliance for Animal Agriculture for supporting this study. And also Ariana Negreiro is supported by a fellowship through VitaPlus Corporation. So why were we interested in this? It was really driven this last 12 months by the forage growing conditions the last year. I just pulled a couple recent articles here about challenges we may have with the 2019 forages, one from John Gazer from Rock River earlier last year, and then at the end of last year, Bill Weiss talking about surviving 2019 forages, some of the challenges with winter kill of alfalfa, and then the delayed harvest and planting and harvest of many forages, including our corn silages. So it kind of prompted us to do this study in this way. Here's some data that John Gazer shared with me a couple days ago, just on comparing October 2017 to October 2019 on the percent precipitation and how much wetter last year's growing conditions were in much of the Midwest of the US. So there's a bit of background here with changes in the availability of our forages potentially this year, specifically due to the unusual cropping seasons or specific locations. I think it's important to explore alternative feed, particularly fiber sourcing. I know Barry will talk more about that later as well. You know, clearly work of Mike Allen and many others done a lot of work in the area of sufficient NDF required for dairy cows, particularly forage NDF, to allow for maximal milk yield and while maintaining rumen function. And then in studies that have looked at non-forage fiber sources, there have been some variable responses in terms of milk and protein, milk fat and milk protein yields. And a lot of this may also then depend on what sources that are being fed, the amount and type of starch and fatty acid supplementation and protein supplementation. So there's a wide variability around that. Now, I mentioned the Michigan Alliance for Animal Agriculture. That's been around for 5 years now, and it's been a huge benefit, I think, to our industry and to applied research. It's allowed many people at MSU to do research beyond the more basic things and start to answer questions specifically available right now. And I had this one last year that was titled Increasing the Use of Non-Forage Fiber Sources to Improve Milk Production and Feed Efficiency. And our initial intent of that study was to specifically focus on non-forage fiber sources or byproduct feeds that we could feed to dairy cows. However, with the forage growing conditions and the concerns with forage inventory, forage quality last year, we kind of did a slight switch on that study and really focused it on how feeding a very low forage diet and then coming back in with some of those non-forage fiber sources is maybe as a way to stretch inventory during these periods, and do a study to see how low could we go, and if we did that, could we maintain high yields of milk and milk components in some very high producing dairy cows. I think, as we all know, dairy producers are paid for the yields of milk and milk fat in most federal orders now. And clearly anything we do to maybe improve the yields of milk components should hopefully improve cow efficiency and cow profitability. As Barry said earlier, most of my research is focused on lipid metabolism, particularly fatty acid supplementation the last few years. And these are included typically for increasing energy density of the ration. And as we and others have showed the last few years, the responses really do depend on which fatty acids are supplemented. We've started to get more interested as well now in amino acid supplementation, particularly how it may interact with fatty acid supplementation. You know, obviously a lot of interest, but primarily in methionine and lysine as potentially most limiting amino acids. There's lots of different ideas around that, lots of different philosophies on feeding those right now. But maybe potentially by supplementing some of these, we can meet requirements without oversupplying crude protein. So in this specific study, our objective was to determine the effects of feeding a low forage diet on the yields of milk and milk components. And our hypothesis was that we could feed a low forage diet containing similar levels of starch, NDF, and rumen degradable protein levels compared to, as I'll show you in a minute, what I would think of as a typical Midwestern diet. And then when we come in with that low forage diet, we were looking at maybe supplementing some palmitic acid and amino acid balancing. And by doing that, we would help maintain yields in milk and milk components. So I'm going to sort of spend some time looking at how we formulated the diets here and then come into the results. For this study, and the study I think ran from December last year through February this year, we had 36 cows. You can see they're all very high producing, about 110, 120 pounds milk, mid-lactation. And we had two treatments. We called a high forage. It could be we could also call it control, or maybe our typical Midwestern diet for mid-lactation cows, and then what we called our low forage diet. But for the purpose of this presentation, I'm going to call them high forage, low forage. With two periods, we had a 4-week feeding period for each, so we had plenty of time for allowing these cows to adapt to these diets to observe changes in milk production as well. So simply, the study was we did milk sampling 2 days every week. We then did body weights 3 days every week, so we could start to look at nutrient partitioning in these cows. Our major data that this data I'm really going to show you today is the data we collected the last 5 days of each sampling period, where we collected milk samples daily, feed ingredients, and orts were collected daily for digestibility. Blood was collected every 15 hours as well, to get a real detailed look at nutrient digestibility, metabolism, milk production. Just going to show the milk production data now because we haven't finished some of that other lab work at this time. So remember what I said earlier on, we're calling this high forage is really our controlled or a fairly typical Midwestern diet. When Ariana and I were putting these diets together, I really need to acknowledge the roles that Stacey Nichols at VitaPlus and Nate Elsing at Caledonia helped us in sort of getting these diets into a sort of the commercial realm of what would be typically fed. So this high forage diet was very similar to our conventional high group cow diet on our farm. And then with our collaborations, we really sort of tried to push this low forage diet to see how low we could go while still making it sort of commercially applicable. So I think both of these diets have a lot of applicability in the industry. So what you can see here primarily here is that we were able to drop the amount of forage in the diet across corn and alfalfa silages and our dry hay. And on a formulated basis, our high forage diet compared to our low forage diet, we're almost halving the amount of forage that was being fed on a dry matter basis to these cows. And that was by dropping both corn silage and alfalfa silage here. You can see we switched the grain sources here. We had a mostly high moisture corn in this high group here on our control diet. We took out all of that high moisture corn and replaced it with dry corn in the low forage diet. Obviously, with the lower amount of forage NDF in this diet, we were concerned about rumen pH and the like. So we reduced the fermentability of the grain that was being fed. And then you can see we increased the a range of different byproducts here: beet pulp, corn gluten meal, soy hulls, cottonseed, all increased in these diets. And actually soybean meal dropped somewhat as well. And that's because we had two different high group packs here. We had our control pack, and then we had our low forage pack here that contained some blood meal and some supplemental amino acids. And that's why the soybean meal level was down somewhat. And you can see here, we also added a palmitic acid enriched supplement to help increase energy density of the diet and help supply some more fatty acids in that diet as well. So I think the thing to remember here, this isn't really one of those studies where we're looking at changing one single ingredient or one single nutrient. It's really a proof of concept study that we could, if necessary, or if someone wanted, we could really reduce forage going into these diets and stretch inventory as needed, or maybe even just allowing you to feed lower forage diets if land-based was an issue, and some of those things and the like. On a formulated basis, as you'd imagine, with some of the ingredients I said we include in that low forage diet, on a predicted intake, the low forage diet would have cost more overall, and on a cost per pound of dry matter as well. So let's keep that in mind as we go through here as well. On a nutrient content basis here, the low forage diet was obviously somewhat drier. Our goal here was to balance these diets, and I was really pleased how this came out. We balanced the diets with total NDF. Now remember, a lot more of this NDF here is coming from non-forage fiber sources, okay? But look at the difference we have in forage NDF. So this is, you hear people talk about 18, 20, 21% of forage NDF as typical forage NDF levels. We pushed it down to 11% forage NDF in this diet. So really getting down to those sort of levels that you may see in some other parts of the country as well. We were able to balance starch content of this diet as well, remember? Now remember, we reduced the fermentability of that starch by pulling out the high moisture corn coming in with the dry crown corn. And then crude protein was held pretty similar as well in these diets. Now, total diet fatty acids went up. Now, some of that's because there's more cottonseed in the diet, but also because we added that palmitic acid enriched fat supplement into this diet as well. And then with the supplemental methionine and lysine, we altered the proportion of methionine and lysine, probably more in line in this study, in this diet, with some of those levels that might be recommended if you were doing an amino acid balance type diet. So let's jump into the results here now. I've just got a few figures to show, and then hopefully that will open that up into some discussion. I think these results can raise some eyebrows and open up to some good discussion here. First thing you will see here is kind of opposite to what we were thinking with lower forage NDF, in which we look at dry matter intake here. Let me just line up these figures just quickly. On our y-axis here is going to be our variable. Here's feed intake. The blue is the high forage or our control treatment, and then the green is the low forage treatment down here on the x-axis. Okay, so you can see straight away we had a big reduction in feed intake, dry matter intake in these low forage cows, about 6 kilos less. If I was at the start of the study, I would have assumed that maybe those cows had eaten more. Now, we don't have the digestibility data back yet. Ariana was working on that, and just before the shutdown here on campus and everywhere else. So we're going to get to those as soon as we can. Even though we had that drop in intake, we held milk yield. There's no significant difference between these two groups of cows in milk yield. Again, these cows are all high producing cows, up around 100 pounds in milk. Now, if we look at milk fat, we can see there's no significant difference in milk fat content. Both groups of cows have good milk fat content, average about 395, just under a 40 butter fat. But with milk fat yield, we had a significant increase in milk fat yield, as one you might expect with the palmitic acid in there, the higher level of cottonseed. We had an increase in milk fat yield, despite that drop in intake, on our low forage treatment diet. Then if we look at protein content, now remember the protein in our control high forage diet was mostly driven by soybean meal, whereas in our low forage diet we had some blood meal in that pack and some supplemental methionine and lysine. We actually we increased milk protein content significantly, and we increased milk protein yield significantly. we were concerned about the protein yield side by pulling out so much of that fermentable corn, and that's one of the key reasons why we came in with some of the amino acid balancing in this study. Again, we increased milk fat yield, we increased milk protein yield as we went through on here. Now, because of those increases in fat and protein yield, as you would imagine, we actually got, as you can see, we actually got a nice increase, just under 2 kilos. So that nearly 5 pounds, 4.5, 5 pounds of energy corrected milk. So when we remember, no difference in fluid milk yield, but we increased fat and protein yield. That 1.9 kilo improvement in energy corrected milk. Now, of course, feed efficiency jumped up considerably in this study. Lower intake, increased energy corrected milk. You know, this is just that simple ratio of energy corrected milk over feed intake shown here. So a big jump up in feed efficiency in these mid-lactation cows here. So obviously, with that drop in intake and the increase in fat yield, protein yield, you know, body condition, body weight could have been a concern. In this study, though, we saw no difference in overall body weight of these cows here. Actually, if we look at body weight change on kilos per day, we actually see there was a trend for it to be slightly higher in those low forage diets. Certainly no indication that these cows were losing body weight or mobilizing body weight to help support this milk production. These body weight change data, I think, is very solid in this type of study. We used the approach that Mike Vanderhaar and his colleagues developed a few years ago. As I said, we did body weights 3 times a week throughout that whole month, and then we can fit a regression line through there to get looking at changes in body weight. So it takes that into account quite nicely, and especially over a longer time period as well. And then with body condition score, again, no indication that these cows are losing body condition. In fact, there was actually a significant for a slight increase in body condition score in those low forage cows. So as I've said, we're really looking forward to getting that digestibility data back to look at energy and nutrient intake in these cows. Because clearly these data would suggest that nutrient digestibility increased significantly in that low forage diet as well. So there's just a summary of the data we saw. If anyone's interested in this, I can share this slide. We are hoping to present this at Dairy Science this summer. We'll have to see where we go with that. But just to summarize, the low forage diet that we designed to try and mimic if we were in a shortage of forage or we needed to stretch our forage inventories. These cows ate less. They gave more energy corrected milk, same level of milk yield, and that energy corrected milk was driven by more yield of fat and protein. And they maintained, and they certainly didn't lose any body weight or body condition. In fact, they gained some across this study. Now, I need to thank Nate Elsing about putting this economic data together in early March, end of February, early March, just to show this. And I'm just showing this purely as an example. Remember, this is going to be changing certainly now compared to what it was a month ago. As I said earlier on, the formulated diet cost was a lot more for that low forage diet because some of those additional additives we had in the diet. But remember, that's assuming that those cows ate the same. So the cost here was more on a formulated, and a cost per pound of dry matter is higher than the conventional diet here. But when you took into account the actual feed intakes we observed in this study, the cost of that diet per cow per day was lower. Obviously, their income was higher, about $1.60 a higher here because that increased fat and protein yield. And then, you know, there's our pounds of fat and protein here, 7.5 versus 7.2 here. So the income per hundredweight was increased, and then the income over feed costs per cow was higher, as was income over feed costs per hundredweight of milk was higher on that more expensive diet in this case. So really, again, a proof of concept that we can formulate these lower forage diets. You know, we did everything we could with this low forage diet to ensure we certainly didn't lose milk production. In fact, we actually gained it. We came in with some of that additional palmitic acid, those supplemental amino acids, to allow us to try and maintain. And in fact, we actually went ahead and improved here. So to summarize, that low forage diet supplemented with amino acids and palmitic acid, decreased feed intake, increased yields of fat and protein, increased feed efficiency. Okay. So we can, here in Michigan, in the Midwest, feed these very low forage diets. Remember, we were down at just over 11% forage NDF. We came in with some supplemental amino acids and palmitic acid, and we actually increased the yield of fat and protein with lower feed intake. Didn't have any negative effect on body weight, milk yield, body weight change. So, you know, we can potentially stretch these inventories in these times if we are concerned about forage quantity or forage quality. You know, we can reduce less forage fed per cow, increase milk production. I realize where we are today may be different to last month on economics, especially with some of the byproduct feeds I hear that increasing in cost with some of the shutdowns that we're seeing now as well. But hopefully a proof of concept to show you there what's possible. Again, Michigan Alliance for Animal Agriculture helps support this work along with VitaPlus through their generous continued support of a master student here, in this case, Ariana Negrera. So I need to thank Matt Wood, Stacey Nichols for that support there. Purdue Agribusiness gifted us the palmitic acid supplement. And then particularly like to thank Stacey and Nate for helping formulate the diets here in this study, and then Faith Cullins and all the Farm South NSU, and then John Gazer for sharing a couple of those introductory slides with me earlier on in continued discussion here. So there's my email address. If anyone wants a copy of some of this or wants to follow up with me, please do so. I'm going to pass it back to Barry, have some questions now. We also have some questions after Barry's talk as well. So thanks, Barry.
Adam, excellent job. Thank you so much. Go ahead and encourage anybody who's on the live stream here to throw in a question in the chat if you have one. In the meantime, Adam, want to throw a question at you. So as you know, I've done some work in this space, and I'm just curious, I would say probably 90% of the time, if there's been a change in feed intake on these sort of lower forage diet strategies, typically it's an increase. And so to me, that was one of the more interesting responses you saw. Any ideas why that might have been the case here?
That's a jolly good question. I don't know exactly right now. You know, these were very high producing dairy cows. I don't know if that has any impact. Again, you would assume the lower forage NDF, they'd have more ability to consume more. I don't know if the higher fatty acid intake with the more cottonseed there in particular, maybe there was some more unsaturated fatty acids post-ruminally that maybe have impacted feed intake. Again, normally we think of that as a negative, but it certainly wasn't a negative in this study. Certainly no indication that they were mobilizing body weight to support that higher milk production. So other than the fatty acid side there, maybe some of those unsaturated, I don't have any, you know, biological reason to think about that now. It will be important to get the digestibility data back to, you know, to see, you know, what was the increase in energy intake these cows are getting. We know, for example, that, you know, we fed a more energy dense diet. We know, for example, the palmitic acid we supplemented that consistently across all of our study increases NDF digestibility. So we're probably getting improvements in NDF digestibility. I think more cottonseed in the diet probably improve fatty acid digestibility. So a number of things I think add up here that would allow us to improve nutrient digestibility across the board. And maybe we were, maybe that was enough. Clearly that looks like that was enough to increase milk production beyond what they were doing on the control cows.
Fair enough. Okay, well, Adam, thanks so much. Great data. I appreciate you being willing to give us an early view of it. I'm going to go ahead and switch gears now. And the presentation I want to share with everybody today is a little bit of a broader view. And really the reason I wanted to dig into this a little bit is just to try to help everyone kind of think through some sort of social sustainability issues around dairy. So within the industry, we maybe don't talk about this on a daily basis, but we're certainly getting challenged on a regular basis as to what's our role in society, what's our role in the food system, and certainly some people are pushing back against the livestock industry in general, saying that we're sort of a net negative impact on society. So I want to try to dig into those questions a little bit and put it a little bit of frame of reference around some of the dietary things that Dr. Locke presented and others have worked on as well. So I think one of the things driving these sort of criticisms or the sort of contentious arguments around what our food system should look like is just this overarching question of whether the planet can sustain 10 billion people. And that's the projections, the current projections for populations around the year 2050. And as probably everyone listening is aware, there's not any new land being created. And the amount of arable land available for agriculture is not likely to change. Really, the only way we can feasibly change that is through some relatively drastic measures to make more pasture land available for row cropping, or to cut down forests, which in the context of the climate change issues and the carbon cycle is probably not a good idea, in addition to other challenges with that. Okay, so when we look at total land available for growing crops worldwide, it's a pretty small chunk of the globe. And then on top of that, one of the things we see is a fair bit, more than half of that land goes to things other than producing human food. Okay, so on the surface already, people get alarmed about that. And in fact, if you look through the literature in the space where people are kind of studying the whole global food system and thinking about ways to improve it, this is something that comes up a lot, is that maybe we have too much land devoted to growing feed for livestock, and that we could have a much more efficient, sustainable system if we use most of that land for directly growing human foods. So this rotating globe here shows a range from green to red, where green is where crops that are grown are going to human food consumption directly, and the red would indicate where most crops are going to feed livestock. And it's basically completely overlapping with relative wealth. Okay, so parts of the world that are relatively wealthy, where agriculture is intensified, we tend to feed a fair bit of the crops to livestock and enjoy animal source foods. And so people that are really focused on concern about sustainability, particularly around the food system, they are told from many sources today that ruminant-derived foods especially are the least efficient way to produce food. And not all of these are necessarily coming from sources that are just out specifically to destroy animal agriculture. I think it's too easy to wave your hands at that and say that that's the case. So for example, this infographic here is not explicitly wrong. It's from National Geographic, which I consider to be a fairly reputable source of information. But as we'll talk about in a minute, despite presenting factual information showing how many pounds of feed are required to generate 1 pound of increase in body mass, may not be the most relevant metric to use to look at efficient food production. So we'll talk about that. But anyway, this is the kind of thing that consumers would often see today when they're just turning to the popular media. Okay, so with that, I'd like to air some grievances with some of these analyses. Okay, first of all, in many of the things, and I think if you can learn to spot these issues, this can be explained to people pretty easily. I see infographics and information that would compare foods on even a mass basis, so a pound for pound basis. Obviously, a pound of meat is far more nutrient dense than a pound of many other types of food, so that's not fair. But even comparing on a calorie per calorie basis is really quite misleading for any high protein food. So even if you include things like legumes, there's really no high protein food that will ever look efficient compared to our staple cereal crops: rice, corn, wheat. On a calorie per acre basis, we're not going to touch that with any high protein source. But of course, we don't just need calories to live on. And so we should be looking at high protein foods on a protein efficiency basis. So there are some analyses that do that, and some of those are still highly critical of animal source foods, which is fine. They're at least trying to be more fair. But even then we have a bit of an issue where, again, if you just say compare growing legumes to devoting land to growing feeds for livestock and consuming animal source foods, that does not account for differences in amino acid profile. And the amino acid profile of animal source foods is the most appropriate for human amino acid needs. That doesn't mean that you can't come up with a vegan or vegetarian diet that has an appropriate amino acid mixture. You can, but it's more complicated. It's not as easy to do. And if you have a limited amount of access to protein, that can be a challenge. And beyond the protein issue, of course, animal source foods are very key sources of other nutrients as well, including certain vitamins and minerals. So the bottom line, this isn't to throw sort of these global analyses completely under the bus. The bottom line is it's just actually quite difficult to come up with an apples to apples comparison, if you will, of different sources of key nutrients, because every type of food has different sort of strengths and weaknesses in terms of meeting human nutritional needs. The second issue, and this one is, people should not fall into this trap because it's so obvious. Not all animal feeds have an equal resource or environmental cost. And this stupid little picture here makes a very obvious point to most people listening. But a pound of crop stubble or hay should not be counted with the same weight as sort of human edible corn. And the infographic from National Geographic that I shared a minute ago is a really bad example of that. So they're counting 6.8 pounds of feed going into beef cattle is essentially equivalent to the feed going into aquaculture, which, if you know anything about aquaculture, and I'm not an expert, but they still to this day have to rely on wild caught fish as a component of the feedstuffs for farm raised fish. So aquaculture, the point is not to throw aquaculture under the bus either, but the point is the resources, the feed resources going into raising fish are inherently far more valuable or have a far greater resource cost than some crop stubble that is a component of feeding cattle. Okay, so comparing those sort of on an equal weight basis of feed is just disingenuous and misleading. Beyond that issue, it's important to recognize when we do some of these global analyses that saying that a lot of land goes to grazing animals, for example, and sort of saying, well, why aren't we raising food for humans instead of being inefficient with that, completely ignores that much of the land around the world is absolutely just not suitable for efficient crop production. In many places, it's simply too arid. There's not enough rainfall to make it a viable place to grow human food crops. In other places, it's too steep that you couldn't raise crops like that without massive erosion problems. And again, everybody in agriculture kind of knows these things, but those nuances are sometimes lost in these global discussions. In addition, and this is an area that more work is needed in, but in terms of sort of justifying ruminant agriculture and production of crops as an efficient way, a component of the food system, we need to better understand what are the positive impacts of perennial forages on soil health and even carbon sequestration. Okay, so some of the really drastic commentaries that are out there suggesting that we should just completely eliminate ruminant agriculture and that would make the globe more sustainable, I can dismiss fairly readily because they employ very little nuance, very little understanding of the complexities of agriculture on the ground. But there are some more reasoned proposals out there that suggest maybe things should look a little different in a perfect system. And this is one that I think is worth engaging with. So this is a concept at least spelled out most clearly in a paper published 11 years ago, where they use the term ecological leftovers to describe sort of one view of how animal agriculture might fit most efficiently into the global food system. So in this concept, the first premise is that arable land that's available should mostly be designated to grow plants for humans to consume. Okay, and we can debate how perfectly that fits, and people would have different ideas on that. I'm not necessarily embracing that, but that's the first premise. The second is that animals should be fed biomass that's unwanted by or unsuitable for humans. And thirdly, that we could justify semi-natural grassland for livestock grazing if it's justified by reasons beyond just meat and milk production. In other words, if we need grazers on that land to sustain biodiversity or conserve soil as opposed to growing crops on it, then it makes sense to at least capture the meat and milk benefits of having ruminants on that ground, or grazers at least. Okay, so again, I'm not presenting this necessarily to endorse this fully, but I think it's an interesting concept. And I particularly want to engage with this concept that we've sort of already dived into with Dr. Locke's presentation. But I think most people in ag wouldn't be opposed to this concept that to the extent that we can, without causing other problems, why shouldn't we use sort of potential waste biomass from other crops, from other processes to help raise livestock? And we've done some reviews kind of on what kind of global advice can you give on using byproducts or co-products, some people like to call them, in feeding dairy cattle. And this is just a brief list of the really wide variety of things that people feed to dairy cattle in different places. And it's, of course, it's very regional. It's based largely on what major industries are present in different regions of the world, because most of these things are cost effective because they are sort of supplied in excess in one location. And so we have huge regional differences. But if you look even just within the United States, if you look around the country, and these are all pictures of feedstuffs that people feed. And of course, California is especially known for the variety and the amount of byproducts they have available. But, you know, Michigan, this isn't uncommon either, to have a fairly wide variety of things available to different farms. Okay, so that was kind of the lead in. I want to now share with you some of the work that my team did. So I just moved to Michigan State at the beginning of 2020. And so this is some work that was mostly completed during my time at Kansas State University. And I especially want to recognize Kayu Takaya and Caroline Ilioya, who were kind of the leaders in graduate school of this project that we just got published in December 2019. So our objective in this study was to kind of ask, how far can we push this concept? So we took cows at the Kansas State University dairy and either fed them a conventional lactation diet and conventional for that part of the world for what we do at that dairy, I'll show you in a second, against a diet that was formulated to include almost exclusively byproducts of human food, fuel, and fiber production. And I say 95% because we ended up adding some things to try to make this palatable and workable. We took that even a step further, though. We said we weren't willing to use feedstuffs that were grown on arable land that could be used for human food production. So you could do this in a somewhat disingenuous way by, say, feeding a very high forage diet, but you've taken land that, you know, was growing corn, for example, that could have been harvested as corn grain and used for human food, and instead diverting it for cows. So we said, we don't want to do that. We want to take this all the way into this eco concept and see what we can do in terms of maintaining productivity in that situation. So our hypothesis was that if we were careful in formulating an extreme byproduct diet like this, that we could support milk yields of at least 80 pounds per day. And really the key focus of this study was, could we, by doing this, improve the return on human edible nutrient investment? So what do I mean by that? So this is really getting back to the idea that not all animal feedstuffs are created equal. Not all should be considered as having the same resource cost to society or environmental cost. And if we can minimize the human edible inputs into the system, we're kind of negating the food versus feed competition debate, turning to this eco concept, and essentially making the dairy system sort of a free lunch, if you will, taking things that are essentially a waste stream and making something useful out of it. So how did we do that? Well, this was tricky. This is not something I would go on a commercial farm that needs to make a living tomorrow and say, start feeding this diet. But let me show you what we came up with. So we used a optimizer and said, here are the nutrient constraints that we need to meet. And you can see in the control diet here, already we were feeding over 30% byproducts. So a fair bit of corn gluten feed, about 5%, 4.5% cottonseed. And so already, and you'll see that in the calculations, a fair bit of feed here coming from non-edible sources, non-human edible sources. In the byproduct diet, we continued to rely very heavily on corn gluten feed, but brought in some hominy feed, wheat middlings, porcine blood meal, a post-extraction algae residue, which was actually a product of a Department of Energy effort working on algae as a biofuel source. So this is after the fat was extracted from that. And then the hardest question for us really was, okay, if you're not going to use dedicated forages that were grown on land, put into forage production, what options do you have to meet fiber requirements? Well, we came up with two. One would be to use crop residues. And in this case, we ended up using wheat straw. So 20% of the diet was wheat straw. The other option that at least we justified in our minds was that in a double cropping system, which works at least in Kansas, if you're growing a winter crop opposite of growing corn, that could in theory be used for human food production, that winter crop should not be counted as taking land away from human food production, because you can't, in that part of the world at least, you can't produce two crops that are both going to feed humans. So either winter crop or forage, crop stubble would be kind of the two options in that sort of concept. Okay. So here's what the mixed diets actually look like. And if you've fed dairy cattle before, I don't think anybody would say that the diet on the right looks like a lactating cow diet that they've ever seen. When we put it together, we probably were a little nervous about whether we'd taken on more than we could chew here. But that's what it looked like. So the diet on the left is the conventional, the diet on the right is our eco diet, we'll call it for short. And again, nutrient spec wise, it didn't line up quite as perfectly as we'd hoped, but when we analyzed these diets at the end, you can see we ended up with fairly typical nutrient profiles across both diets. Well, so I do have to acknowledge here that one issue we had in feeding the byproduct diet is we did have one cow that went on hunger strike. She absolutely would not eat this feed. And after a couple of days of her eating essentially nothing, we ended up giving up and taking her off the study. So that's important to acknowledge. Again, this is a very extreme example. And there are some cows that just couldn't manage that. However, in general, we were pleasantly surprised by how this performed. So to set you up on these graphs here, this is on the left, just raw milk yield, and then fat corrected milk yield on the right, in pounds per day on the y-axis. And the control groups are on the left side of each graph and byproduct on the right. And we split this up into cows that were multiparous and primiparous. So we can see here is that going from the control diet to the byproduct diet, we gave up about 8 pounds of milk and actually over 12 pounds of fat corrected milk in the multiparous cows. Okay. But again, given the constraints we put on ourselves, not terribly surprising. What was interesting is in the primiparous cows that had lower nutrient demands, no change in milk yield and a very marginal change in fat corrected milk yield. It's not statistically significant. So one way that I think through this is by putting those shackles on ourselves in terms of how we put that diet together, we were able to formulate a diet that could meet the needs of the cow, making the lower 80s in terms of milk yield, but it couldn't really keep up with a cow that wants to make 95 pounds of milk or more. Okay, so not too far off, actually probably better than I thought it might work once we actually saw the diets. So here's the trickier part. So when we actually go into analyze this and ask questions about the return on human edible nutrient investment in this system, you have to start asking, well, what's suitable for human consumption? It seems like an easy question, but when you actually dig through different papers and how they've handled it, it's all over the board. Okay, so again, we wanted to be as tough on ourselves as we could be, if you will, or as tough on the dairy system, and say, let's really look carefully at this system and see what could actually go into the human food supply. Okay, but we wanted to make it feasible as well. So we ended up looking at 3 different scenarios. So the first scenario we looked at would be equivalent to our current US food system, where we have nearly unlimited choices. Okay, the coronavirus scenario aside, we're used to having nearly unlimited choices for foods. And in this scenario, there's things that people simply don't eat. Okay, but we absolutely, of course, need to acknowledge that the corn grain going into these cows could have gone to human consumption. Soybean meal that could have been used to produce tofu or other products. We should consider that as human edible. And then this is something some people don't do. So the corn silage component of this, again, trying to be as fair as possible, we said we really should consider the corn grain component of that as human edible, because it is. And just because you chopped it up with all the forage doesn't mean that it shouldn't be considered in that. In the byproduct or the eco diet, really the only thing that we considered human edible in this scenario was molasses. Okay, so then we went through and you said, well, among the things that are human edible, how much protein was actually provided to each individual cow per day in that scenario? And in the control diet or the conventional diet, about 1.5 kilos of edible feed protein, human edible feed protein, was provided per day. And the return on that was about 1.2 kilos of milk protein. Okay, so we'll come back to that in a moment, but I'm just wanting to walk you through how we did these analyses. In the eco diet, very, very little feed protein available. We didn't consider non-protein nitrogen as human edible feed for obvious reasons. So almost no inputs, and again, just slightly lower milk protein output there. So then we thought about another scenario. So what about a scenario where we don't have such unlimited food supplies and people have to turn to things that they maybe currently would turn their nose up against? So certainly hominy feed, it's a little different than the hominy product that you can find in a grocery store, but not so different that humans couldn't eat it. So we thought it was fair in a thrift scenario to consider hominy feed to be human edible. And then wheat middlings, it'd be sort of like oat bran or wheat bran. It's certainly possible that you could mix that into some food ingredients and get something edible out of it. Okay. So on the conventional side, again, no real changes here. We didn't bring anything else new in terms of being consumed by humans. But in the eco diet, now we've jumped to about 1.1 kilos of edible feed, human edible feed protein per day. Okay, and obviously output isn't any different. So these are just different ways of looking at the same data. So we then thought about the most extreme scenario. Okay, so here we're starting with a thrift scenario, and now we've said that land is highly limiting as well. And again, to be completely fair, then I think we have to consider that land devoted to producing alfalfa, we should at least acknowledge that that land could have gone instead to growing a mixture of a cereal grain and an oil seed to produce protein and energy in a mix that would match that of milk. So in other words, that whole concept of diverting land from making feed for animals to making food for direct human consumption. And so we put in a factor saying, accounting for the land that was used for alfalfa and considering if we had diverted that to direct crop production for humans. So in that scenario, our resource cost, if you will, is equivalent to 2.1 kilos of human edible feed protein per day for those cows. And no change here on the eco side. Okay, so that's how we thought through this. So one of the points I want to make is whether or not different components of the food system look efficient depends a whole lot on the assumptions you make. And compared to some of the work that's out there in terms of global food system analysis, this analysis that we did, which took a fair bit of time, is tiny. People are trying to do things like this, encompassing the entire globe, encompassing all food products going through the system. They have to make an infinite number of assumptions. And this isn't to criticize those analyses, but again, it's very, very hard for them, even with the best of intentions, to incorporate all the nuances that are here, even if we look at a single product in just a couple of small different scenarios that are all potentially feasible. Okay. So if we boil this down a little bit and sort of ask a simpler question, in our current US scenario, which I would say is essentially the choice scenario, what's the return on human edible investment in the dairy cow? So in other words, are we actually wasting resources by feeding dairy cows and getting the milk for human consumption? So on the conventional diet we fed in these studies, on an energy basis, we recovered about 95% of what we put in. Okay, so there's about a 5% loss there. And on the protein side, we recovered about 82% of what we put in. So again, about an 18% loss there. Here again, as I pointed out before, there's some nuance lost already. So milk protein coming out from an amino acid basis and from a digestibility basis, most likely is not going to be the same as the feeds going in. In fact, it's going to be upscaled protein quality. So I wouldn't necessarily say that we're wasting 18%. The recovery is not massively greater than 1, but I think on an actual nutritional basis, it's probably pretty close to 1. However, just to say how extreme can we go in terms of cranking this up with our very crazy eco diet that we fed, we could get that energy return on human edible inputs to be 7.7. Okay, so for every calorie of human edible feedstuffs that we put into those cows, we got over 7.5 calories back. And on the protein side, it's even more extreme. So for every gram of human edible protein we put in those cows on the eco diet, we actually got 20 grams of human edible protein back out. Okay, so if this really is the key metric that we want to use to drive a better food system, if you will, we have a lot of room that we can shift this in feeding dairy cattle. Okay, but I think it's also important to recognize and ask what forms of malnutrition are actually the most likely on a global level. So some people in the fear-mongering world don't recognize or know this, but today we actually have plenty of calories, plenty of protein, and actually plenty of every nutrient, as far as I can tell, to meet the needs of everybody in the world, and probably to meet the needs of 10 billion people. The problems are, A, in doing so, are we having unacceptable environmental costs? B, are our food systems, distribution systems such that those nutrients are wasted in some places and not delivered in sufficient quantities in other places. Okay, and so this is a nice paper published a couple of years ago now in the same journal that we published in that tried to assess globally what's the supply of all the different essential nutrients for humans and which ones are the most at risk of being deficient. And this is not the only nutrient that was considered to be sort of borderline, but one of the ones they highlighted was lysine. And this is a direct quote from the paper: whilst the average diet is not lysine deficient, if meat and dairy products were removed, the global food system would be severely lysine limited. Okay, so let's think about lysine then. So if we went through the same analyses for essential amino acids, and even in the conventional diet where we're not really targeting a massive return on human edible inputs, we got about 1.5 grams of lysine back for every gram of human edible lysine into the system. In the eco diet, under this choice scenario, that becomes a massive number. So for every gram of lysine we put into the cow, we got 471 grams back out. And I think, you know, some of these numbers really just point to, I think, the two incredibly cool things about ruminants. A, their ability to degrade fiber and turn that into energy that can be then used to produce much more nutritious products like milk. And B, their ability to upcycle nitrogen. So they can take nitrogen sources that would be toxic to humans and actually turn them into true protein that can nourish people. Okay, so a few caveats and cautions here. I don't want to overstate, you know, the work that we did. First of all, this is only assessing a very narrow question. So if we're only asking what can we do in terms of loss or gain of human edible nutrients in feeding lactating dairy cows, and I definitely want to acknowledge that the eco diets that we tested, I showed one of them, are not feasible for industry-wide use currently. The very first simple reason for that is if everybody were to jump on these kind of diets, all these byproducts would be used up very quickly. So we don't have adequate supply to even do this if we wanted to right now. But it's again, it's kind of a proof of concept. How far could we take this in theory? And the other thing we have to acknowledge is in the real food system, we don't have the luxury of just looking at carbon footprint or just looking at human edible feed return on investment. We have to also consider economics, the resilience of the system, labor efficiency, energy efficiency, water efficiency, and all those things have to be combined. And often when we see, really highly critical pieces of data, they're looking at a very narrow prism from which to look at a system that's very complex and has to fit into a world with lots of things going on simultaneously. Okay, with that being said, I think one of the really interesting things from this, again, we tried to be as tough on the dairy system as we could without being unfair. And I've become at least convinced that at least for some nutrients like lysine, it's pretty clear to me that our modern dairy production systems do give us a net return on human edible inputs. Okay, so I have no trouble sleeping at night. So this is a graphic from the EPA kind of detailing what are considered to be the best ways to do with excess food supplies. And it tends to be built on wasted human edible foods, but it also kind of applies, at least in part, to what about those components of crops that are not used. So again, think about cottonseed is the one I love to talk about. So your t-shirt's made of cotton. There's a very nutrient dense seed that's not used to make your t-shirt. Humans can't eat it. There's a toxin there, but it's a terrific feed for cattle. And if you took cattle out of the equation, what options do we have? And you can go down this upside down pyramid here and see that, yeah, there's things we could do, but from an environmental standpoint, they're far less preferable to using it to feed animals and produce human food out of that. Okay. So I think to me, and we can argue again about details, but in general, livestock and especially ruminants play a really critical role in making nutritious food out of these products that would otherwise just be lost from the system. It doesn't mean we need to push it to the extreme, but in this experiment, we were just asking what would happen if we tried that. Okay, so this is my contact information. Love to engage with you on these topics if you're interested. And